So, hello everyone. Today we are going to discuss about load balancing strategies and how to implement them with explained examples. So, in the age of cloud native applications, performance, scalability, and fault tolerance are more important than ever. So, load balancing is a cornerstone of modern infrastructure that intelligently distributes incoming requests across multiple servers. So, in this video, we'll not only learn about various load balancing strategies, but also how to implement them with hands-on code examples and clear explanations. So, first, what is load balancing? So, load balancing is a method of efficiently distributing network or application traffic across multiple servers. It helps achieve high availability, performance, scalability, and security. So, high availability means it prevents downtime by routing around failures. The performance means it distributes traffic to avoid server overloads. Scalability means it allows horizontal scaling by adding servers, and the security means it masks backend infrastructure and mitigates DDoS threats. So now, load balancing strategies with the implementation and code explanations. So the first strategy is the round robin. So here the round robin sends each new request to the next server in line. After the last server, it loops back to the first. So it is best for stateless applications and identical servers. So here you can see this is in Nginx code here. So here the upstream backends defines a group of backend servers. Requests are sent to server 1 and then server 2 and back again in order in a loop. So here these proxy pass directive send incoming traffic to the upstream group. So the second strategy is the weighted round robin. So here the concept is a modified round robin where servers received traffic in proportion to their weights. So it is best for servers with the different performance capabilities. So if you see the example here, the weight here you can see the weight as 3. So it means server 1 will receive 3 requests for every one sent to server 2. So it is useful in heterogeneous environments with uneven server resources. So the third strategy is the least connections. So the concept is traffic is sent to the server with the fewest active connections. So it is best for long-lived connections like database or video streaming. So here you can see the example here. So here the least connection activates the least connection strategy, and it is useful for systems where the number of current users matters more than just server count. So here this feature is available in Nginx Plus only, not the free version. So and also not the open source version. So the fourth strategy is weighted list connections. So the concept is it combines the number of active connections and server weights for smarter traffic distribution. So it is best for cloud and hybrid deployments with varying server capacity. So here you can see this is the example. Here this balance list connection distributes traffic based on the fewest active connections. So here the weight allows more powerful servers to handle more connections, and this check enables health checking also. So the fifth strategy is the IP hash. So here the concept is the client's IP address is hashed to determine which servers will handle their request, ensuring sticky sessions. So it is best for stateful apps like banking, cards, and gaming. So here you can see the Nginx example. So here this IP hash ensures the same client IP always hits the same server. So this maintains session persistence without extra configurations. So here the sixth strategy is a least response time. So here the concept is it routes traffic to the server with the best real-time performance, lowest latency, and fastest connections. So it is best for real-time applications like stock trading or VoIP. So here the HA proxy with monitoring. So this is typically implemented using external agents or scripts that measures response time and update HA proxy configs. So if you see the explanation of this, HA proxy doesn't natively support least response time, but you can simulate it by dynamically adjusting server weights based on response metrics gathered by an external monitoring system. So here the seventh strategy is resource-based load balancing. So here the concept is it makes decisions based on real-time CPU, memory, or disk usage. So it is best for resource-heavy applications like video processing or analytics. So we use this resource-based load balancing normally in the Kubernetes. So here we give the minimum replicas as 2 and the maximum replicas as 10 here. So here these are the resource limits. So here you can see the average utilization is 50. So that's how we can use this resource-based load balancing. So here the explanation is it automatically adjusts the number of pod replicas based on CPU utilization. So it ensures traffic is routed to healthy, capable pods in real time and works best with cloud native systems like Kubernetes and service meshes like Istio. So the eighth strategy is the random. So here the concept is it assigns each request to a randomly selected server. So it is best for simple microservices without session needs. So here, this is the proxy example here. So here, this balanced random ensures each request is randomly routed. So with a high volume of requests, randomness statistically balances the load well. So here we can see the strategy cheat sheet here. So if the use case is stateless apps, the recommended strategy is to use round robin and random. So the tools which we use in these are Nginx and HA proxy. For the uneven server capabilities, it is recommended to use weighted round robin. It is also same the Nginx and HA proxy. So for the long-lived connections, the recommended strategy is to use least connections. The tools are Nginx plus and HA proxy. So here, if the use case is session persistence, it is recommended to use IP ash strategy, and the tools here are only Nginx. So if the use case is latency sensitive workloads, so it is recommended to use the least response time strategy. So the tools are HA proxy plus monitoring. So if the use case is resource heavy systems, the recommended strategy is resource based. So the tools used in these are Kubernetes plus HPA. So in the conclusion, load balancing is a key part of building fast, reliable, and scalable applications. It helps spread the traffic across multiple servers so that no single one gets overloaded. By choosing the right strategy like round robin for basic setups, IP hash for sticky sessions, or resource based for heavy workloads, you can make your system run more smoothly. So the different tools like Nginx, HAProxy, and Kubernetes make it easy to set up these strategies. So each method has its own strengths, and the best one depends on your app and traffic needs. So in the simple terms, load balancing helps your app stay online, handle more users, and give a better experience. So this is about load balancing strategies and how to implement them with explained examples. So that's it for today. So yeah, thank you.